friends, in this video we're working with the comparison test. And before we use the comparison test, it's important to make sure that we have a pretty solid understanding of some of our more known and popular series that we've worked with in the past. So those would be like, for example, our geometric series, P series, harmonic series. Some of these more popular series, you have to have an understanding of how they work and how to tell if they're convergent or divergent, because we'll be using them to help us determine whether given series that we're working with, like your homework problem that you're trying to figure out, whether these given series are convergent or divergent. So before we get started, the comparison test states that if we're working with a known series and we know that the known series is convergent, then we can conclude that our given series converges when we've made the comparison and determined the fact that the known series is greater than the given. Similarly, if the known series is divergent, we can conclude that the given series is divergent when we know that the known series is less than the given series. So to kind of help us demonstrate that, I have a series we're working with right here. And one important thing that we have to know before using the comparison test, actually a key part of the comparison test, states that the series that we're comparing have to be positive. So when we're comparing this series, we first have to make him positive. So in order to make the comparison, in order to make the inequality, that part has to be positive in the inequality. So in order to do that, we're just going to take the absolute value of this guy. So we're going to take the absolute value of negative 5n over n cubed plus n plus 1. See, since we have that negative sign here, right? So when you take the absolute value, we know the entire bottom is going to be positive because we're only plugging in positive values from 1 to infinity. So this is positive. Our 5 times n is going to be positive, so this just gets rid of our negative sign right here. So all we have left with is we're going to have 5n over n cubed plus n plus 1. So when we make our inequality, this is what we're going to have to compare. So in order to compare, we have to figure out, though, what known popular series can we compare with this guy? What do we see? Well, when we look at the series, right, we see that, well, if we were to make a couple of changes, if we go through it and we, rule out like things like geometric series, we could see that, well, if this was just a little bit different, he'd almost be a P series. And how would we see that? So if we were to rewrite this guy, if he was just negative 5n over n cubed, let's say, and we just get rid of the n plus 1, this would be the same thing as saying we have a series from n equals 1, right? Our n's would cancel out. I'm going to pull my 5 out front. So we're going to have negative 5. We're going to have infinity, the series from 1 to infinity. And we're going to have, our n's will cancel out, so we'll have 1 over n squared. That's a P series, right? So we know that this is a P series. So in order to determine whether it's convergent, we have to identify our P, which is 2 here. And since 2 is greater than 1, we know that this P series is convergent. Cool. So now we have to compare the two series. So we have to, once again, compare the positive version of this series here. So when we take the absolute value, our negative sign will go away. So yeah, I can't stress that enough. Make sure you're comparing the positive. Once you write out your inequalities, you have to make sure you're comparing the positive series. So take the absolute value of them before you make your comparison. Okay, so here we have 5n all over n cubed plus n plus 1, and we're comparing that with 5n over n cubed, which it's kind of hard to see, so I'm going to rewrite him real quickly. 1 second, friends. Let me erase this for you. So we have 5n over n cubed. There we go, that's better. Okay, so now we have to make our comparison. You have to determine which one of these is greater than the other. So we see our numerators are the same, so that's cool. What's different is our denominators, right? Here we have n cubed plus n plus 1. here we just have n cubed. So since we're adding on these additional n's and 1, this denominator is going to be greater than this denominator because, like I said, we're adding on extra stuff. So if this denominator is greater than this denominator, what that means for this series overall is that it's going to be less than this one. And why is that? Well, let's think of an easy example, right? If we compare 1/4 and 1/3, 1/4 is a greater denominator than 1/3, but we know 1/4 is less than 1/3. So that logic kind of applies for up here too, right? This is a greater denominator, so he's going to be a smaller fraction in comparison with this one. So now that we've made this inequality, we know that our known series is greater than our given series in our comparison. We know that, so we know our known series is greater than our given. We know our known popular series is convergent. So since it's convergent and it's greater than our given, because of these two things, we can conclude that our given series is convergent. So that means our original series that we were working with, this guy right here, is convergent. And that concludes our work on the comparison test.